At around 5 in the morning, on a stretch of road roughly 40 miles outside Las Vegas, Dave Caussin and his wife sat in a rented truck that had run out of fuel. California was behind them. Chicago was still almost the entire country away. In the back of that truck was a milling machine fitted with a tool changer, a device their family had spent years developing. If they failed to get it to the 1974 International Manufacturing Technology Show, it would remain what it had been inside the Fadal shop, a clever solution nobody outside their own walls had ever seen. What they had was conviction, not much else. What they could not have known was that 21 years after that truck ride, Fadal would be sold for roughly $180 million after rising to produce about 54% of all vertical machining centers made in the United States. For a time, it would stand as one of the biggest direct rivals to Haas Automation in the American CNC VMC market. This is the story of Fadal. If you enjoy stories about the companies, people, and decisions that shaped the industrial world, subscribe to the Gear Archive and follow along. Francis de Caussin had been trained as a toolmaker in the automotive industry, a trade that teaches more than how to run a machine. It teaches how a part is held, how cutting forces travel, how a tiny error in a fixture can ruin an entire batch, and how wasted motion quietly destroys profit. That background taught him to look past the machine itself and see the real cause of a slow, unstable, or expensive process. In 1953, the family moved from Detroit to Van Nuys, California. Francis found work as a machinist in a local shop, but he wanted something of his own. 2 years later, he began taking side jobs in the family garage with a lathe loaned by a manager in exchange for a share of the profits, along with a shopsmith bought on installment. His wife, Gladys, worked for a mail-order company to help make the payments. Adrian, David, and Larry were still young when they began working with their father, but that garage became a technical school tied directly to the monthly bills. If a machine sat idle, the shop earned nothing. If a machine lacked travel, larger jobs had to be turned away. So the family modified whatever stood in the way of the work. Francis installed a riser block on a mill. Larry temporarily fitted a second motor to a lathe spindle. David lengthened a hand crank to gain more leverage. None of those changes were commercial products yet. They were acts of survival. But they also explain why Fadal would later design machines the way users actually needed them. In 1957, the name Fadal was created from Francis, Adrian, David, and Larry. In 1961, they used Larry's $2,500 in savings to go full-time, rented a shop of about 800 square feet in North Hollywood, and bought a lathe on the strength of Francis's credit. The fragility of a small business became painfully clear in 1965, when major customer Summers Gyroscope went bankrupt and left behind a $17,000 unpaid balance, nearly 7 times the company's original starting capital. The family survived because Southern California was in the middle of an aerospace, defense, and space race boom. Fadal took on work connected to Surveyor, Voyager, satellites, landing gear, and later the Space Shuttle fuel system. Those projects brought in revenue, but they also exposed every weakness in the shop. Any slow operation, any instability, any setup issue was multiplied across entire batches of precision parts. By the late 1960s, Fadal's problem was no longer finding work. It was getting more of that work finished inside a fixed number of hours. The answer seemed to arrive in the form of the most modern machine they had ever bought. Instead, one missing feature on that machine changed the direction of the company forever. In 1969, Fadal spent $25,000, 10 times the capital it had used to launch the shop years earlier, on its first numerical control machine, a Bridgeport with a superior electric control and a third-axis spindle wizard. For a job shop in the late 1960s, NC was a major leap. A programmed machine could repeat motion and cutting paths more consistently than manual work. But this Bridgeport was not yet a full machining center, and it had no automatic tool changer. Every time the operator needed to switch from drilling to milling, or from a roughing tool to a finishing tool, the machine had to stop while someone reached for a wrench, removed the old tool, and installed the next one. One tool change would not kill a shop. Dozens every day meant that an expensive machine spent minute after minute producing no value at all. Worse, every manual interruption added another chance for the very kind of error NC was supposed to reduce. The family began with a power drawbar to speed up tool clamping and release. Then David asked the obvious question. If the machine could already move by program, why was the operator still standing there waiting to change tools one by one? David focused on the mechanics of a changer. Adrian handled the electrical and control side. Larry worked out how to manufacture repeatable assemblies instead of just making one prototype by hand. The result was an aftermarket tool changer that did not replace the entire machine, but fixed the exact bottleneck every similar shop understood. In 1972, Fadal began developing the product seriously. By 1974, they needed to put it in front of the industry. The obvious stage was IMPS in Chicago, one of the most important events in machine tools. Getting there meant hauling a demonstration machine all the way from California. So Dave and his wife rented a truck and headed east across America carrying a product, a hope, and not much margin for error. The trip did not go smoothly, but they made it. At IMPS, shop owners saw a milling machine that no longer forced the operator to stop and reach for a wrench every time a tool changed. They immediately understood the time savings. The show did not turn Fadal into an empire overnight, but it put the company in front of the right people. Demand then grew faster than Fadal could supply it. Matchmaker in England reportedly grew tired of waiting and copied the tool changer because Fadal could not deliver fast enough. Operationally, that was a failure. Strategically, it was proof that the product solved a real problem. Summit Engineering in Bozeman, Montana, saw a different opportunity. It paired the product with an affordable control, paid $75,000 for the design and patents, renamed it the Bandit Quick Draw, and had Fadal continue building more than 2,000 mechanical assemblies. The sale of the design and the profits from production gave the family capital and experience at a scale they had never had before. They could have remained a successful accessory supplier, but after improving other people's machines, a larger question emerged. If they could design the part that made someone else's machine better, why not build the whole machine themselves? In 1976, Fadal began the most ambitious project in company history, a complete machining center with its own CNC control. Adding a tool changer to someone else's mill was one thing. Building a full machining center meant taking responsibility for structural rigidity, spindle power, three-axis accuracy, tool change timing, and the way software, servos, and electronics work together. If any one of those systems failed, customer confidence failed with it. The family had one major advantage. The three sons did not all bring the same skills. Adrian developed Fadal's own control at a time when many American builders were buying controls from outside suppliers. That choice meant Fadal would have to own the consequences when software or electronics failed, but it also gave the company control over the user interface, operating logic, and a portion of machine cost. David took charge of mechanics, the tool changer, and the machining center itself, turning automation from an add-on into a built-in part of the machine. Larry worked closer to the line, building fixtures, tooling, and processes that would let the machine on paper actually be manufactured fast enough. If every unit needed weeks of hand fitting and depended on a few highly skilled craftsmen, Fadal would never hit its target price. Francis provided the common philosophy beneath it all, the toolmaker's instinct to treat a machine as a system that could be improved, to see time as a cost, and to reject arbitrary limitations just because the original builder had accepted them. By the late 1970s, the prototype became the VMC 45, a vertical machining center with a 45 taper, a 4-speed gearbox, and a geared head. It was positioned as an upper-end machine at around $110,000. At a time when Japanese machines were selling near $160,000, that gap looked large enough to justify the risk of buying from a newer, less established brand. The first VMC 45 sold in 1980. For the first time, the family name appeared on a complete machining center, rather than an accessory mounted to someone else's machine. Then the market moved. According to Larry de Caussin, Japanese competitors dropped prices from around $160,000 to roughly $90,000, leaving Fadal as a little-known builder trying to sell a more expensive machine than suppliers with stronger networks, deeper experience, and international momentum. After years of development and the capital earned from the tool changer business, the VMC 45 had been overtaken by the market almost as soon as it appeared. So the family had to ask the hardest question in manufacturing. What do you do when your first full machine is wrong? Fadal could not make the VMC 45 into a bargain simply by explaining it better. They had to redesign the equation. The family looked at machining centers already on the market and saw features many small job shops did not truly need. Every layer of complexity drove up the selling price. Every special option slowed production. Every uncommon part made service, spares, and troubleshooting harder. So Fadal moved toward a simpler machine. The goal was no longer to build the most impressive machine on paper. The goal was to build the machine the family itself would have wanted to buy back when they were still taking work in a garage. It was the same basic logic that would later help Gene Haas build Haas Automation into a manufacturing empire. Initial price was only part of the decision. A machine also had to reach production quickly. Operators had to be able to learn the control. When something went wrong, a shop had to diagnose it without waiting for a specialist to fly across the country. Parts had to be available. That was the formula Fadal began optimizing. Affordable purchase price, high enough speed, a control simple enough to learn, consistent enough configuration, straightforward enough maintenance, broad enough capability for real shop work. Notice what is not in that formula. Not the best machine in the world. A theoretically perfect machine that took months to master and cost too much to repair could be the worst purchase for most small businesses. Fadal sold its first redesigned machine to Columbia Machine, where Francis, Dave, and Larry had once worked. There was something deeply symbolic in that moment. Men who had once run other people's machines had returned with one carrying their own family name. Inside the company, though, confidence was not absolute. Dave later recalled that the family used to joke that if they went bankrupt, at least the auction would look impressive. A machining center business could burn money much faster than an accessory company ever could. Customer response began easing those fears. Buyers liked the speed, liked the price, and recognized that the machine had been designed for shops like theirs. In 1983, the first 5 VMC-40s proved the formula could sell. That machine became the foundation of the product line that made Fadal famous. Adrian kept developing the control so the company would not be fully dependent on imported systems and could maintain its own operating language. He also imposed configuration discipline. Dave argued that many American machine builders had damaged their own efficiency by accepting too many one-off machines in special colors, special controls, or unique option combinations that only appeared once. Every such exception fragmented software, boards, documentation, and service. Fadal accepted that some customers would be told no, so the rest could get machines faster and support more easily. A technician could arrive already knowing the structure of the machine, carrying the right parts, and solving the problem rather than spending the first visit trying to understand an unusual configuration. Larry turned that consistency into productivity through fixtures, tooling, and process design. Remove one motion from one assembly step, and the savings multiply across thousands of machines. In 1984, the family made a full commitment to VMCs. If the machining center business failed, there was no backup revenue stream left, but if they kept dividing their attention, the line would never meet market demand. Fadal bet everything on the simpler machine, and this time customers followed. To understand why Fadal then grew so quickly, you have to see the 1980s market from the perspective of a small job shop owner. Maybe he had a few manual machines, a small staff, and a customer list that did not guarantee next month's work. CNC promised productivity, repeatability, and more complex jobs, but expensive imported machining centers could threaten the whole business. The debt remained even if orders vanished or the machine stopped running. At the same time, many established American builders were still focused on large, specialized, expensive equipment, while Japanese machines were taking market share with stronger controls, rising quality, and aggressive pricing. Fadal was not going to outgun everyone on pure technology, so it competed by lowering the barrier to entry. By 1993, the company was selling 9 machine models priced from roughly $36,500 to $148,000. That range let Fadal serve both a tiny shop setting up a machine in a warehouse and large institutions such as United Airlines and the Jet Propulsion Laboratory. A machine might be capable of aerospace work, but the logic behind buying it still had to make sense for someone who only owned 1 or 2 machines. The machines were often described as no frills, less showy, fewer parts, simpler electronics than many competitors. Fadal also used its own machines to make components for the next machines, so productivity claims were being tested every day in front of the design and production teams themselves. The family kept using American-made castings because they viewed the domestic foundry base as an industrial asset worth preserving, even though that decision meant they had to win on cost without relying on the cheapest possible iron. Adrian once said the company did not need import restrictions to compete, but in principle did not want to import the iron. The economic answer, in his view, was productivity and standardization. At its peak, Fadal said the factory produced around 10 machining centers per employee per year, while some older line builders were closer to 1. That comparison does not capture every difference in product complexity, but it reveals the model. Fadal was not treating every order as a special project. It was building many similar machines, learning through repetition, and squeezing cost out of the process. That same consistency improved service. Technicians familiar with the machines could arrive with better diagnoses and the right parts. The control's telephone modem also allowed staff in Chatsworth to inspect customer programs remotely in an era before the Internet was common. A machine optimized for price, speed, and serviceability was never going to win every argument over rigidity, finish, or ultimate lifespan against premium iron. In fact, the debates machinists still have over Fadal's strengths and weaknesses are part of the point. Fadal occupied a specific place in the market. It was a working machine built to earn money, not to win a purity contest. The formula appeared at exactly the right time. Thousands of American job shops needed to move from manual equipment or older NC machines into CNC, but could not risk everything on top-tier imports. Fadal was not selling the dream of owning the best machine regardless of cost. It was selling a path into automation that did not put the whole business on the table. The numbers changed rapidly. In 1985, Fadal had roughly $5 million in revenue and about 75 employees. 8 years later, even the family began to worry about how fast they had grown. Growth in machine tool manufacturing does not only show up on an income statement. It takes floor space from the moment castings arrive until finished machines are loaded onto trucks. Fadal expanded into as many as 11 separate buildings, a practical short-term solution that fractured the production flow. Every time a part moved between locations, it needed a forklift, a schedule, and another chance for delay. So in 1993, the company moved into a 220,000 square foot facility in Chatsworth, worth about $10 million and owned by the family. The operation was brought together into one system, where Fadal machines produced components for the next Fadal machines. The scale reflected the growth. Revenue rose from around $5 million in 1985 to nearly $110 million in 1993. Headcount grew from 75 to 240. Backlog stretched to 8 weeks. Monthly production was expected to rise from 120 to 150 machines. In a segment many had assumed belonged to Japanese builders, Fadal was taking customers with machines made in California. The Los Angeles Times described the company as having almost single-handedly broken through in the low-cost VMC category. One analyst called the product the Volkswagen Beetle of the machine tool industry, not because it was glamorous, but because it was widespread, practical, and exactly what many buyers needed. About 90% of the machines were sold in the United States, but a network of 50 distributors had already placed more than 6,000 units around the world, including in Japan. Larry still saw the danger inside a long backlog. If a customer had to wait 8 weeks, a competitor could step in and promise something sooner or cheaper. Fadal had learned that lesson before, when Matchmaker copied the tool changer and Japanese machines erased the VMC 45's original price advantage. Revenue reached $138 million in 1994, after averaging 27% annual growth from 1991 onward. By 1995, the company employed about 320 people and had sold nearly 10,000 machining centers. Reports at the time of the sale stated that Fadal produced roughly 54% of all VMCs manufactured in the United States, not 54% of the entire market. When imports were included, it held close to 1/3 of total domestic VMC sales. The company was strong, but time had moved on. Francis and Adrian had died. David and Larry were approaching retirement. The family now faced a question every founder eventually faces, whether they want to or not. How does a family company outlive the family that built it? In a machine shop, a bad part can sometimes be recut. A bad decision cannot. In the early 1990s, the de Caussin family brought in outside advisors to evaluate Fadal's future and found that every option carried a cost. Keeping ownership meant the founding generation kept carrying the risk. Breaking up shares could dilute decision-making. Selling to management or relatives required very large financing. Selling to an outside corporation solved liquidity and succession issues, but ended family control. Giddings & Nuys was one of the world's largest machine tool builders. It had the history, network, and product breadth Fadal lacked, and it wanted exactly the part of the market where Fadal had become strongest, small vertical machining centers. In April 1995, Giddings & Nuys bought Fadal for about $180 million. Financially, it was an extraordinary outcome. Larry's $2,500 contribution in 1961 had become part of a valuation 72,000 times larger 34 years later, without even accounting for inflation, prior profit withdrawals, or reinvested capital. Industrially, the logic was clear as well. Fadal brought growth, product, and market position in the low-cost VMC segment. Giddings & Nuys brought global scale and access to broader markets. To many observers, selling at that moment looked like a mistake. Revenue had just reached $138 million. Fadal was producing more than half of all VMCs made in the United States, but the founders had spent 4 decades building the business. They had earned the right to retire, and succession inside a family company is a real problem, not a romantic one. Keeping the company in the family did not guarantee a successful transfer either. Once the deal closed, the people who knew the product most intimately no longer had final authority. The brand began moving through a different kind of history. The easiest mistake in telling Fadal's story is to draw a straight line from the 1995 sale to the closure of the Chatsworth factory in 2008, as if one event mechanically caused the other. The 13 years in between were filled with changing owners, technological shifts, and economic cycles. What can be said with confidence is something simpler. The distance between the brand and the people making its key decisions kept growing. 2 years after buying Fadal, Giddings & Nuys itself became an acquisition target. It rejected a hostile bid from Harnisch-Fager Industries, then accepted a higher offer from Caussin in a deal worth around $675 million, announced in 1997. Fadal changed hands again, this time as an asset moving with its parent company. In 1999, Caussin & Krupp merged into ThyssenKrupp, placing the Chatsworth VMC builder inside a vast industrial portfolio that ranged from steel to technology. Large corporate ownership can bring capital, purchasing power, and networks a family company does not have, but it also shifts priorities upward. Capital may be sent to a more profitable division. Product lines must fit global strategy. A factory in California is no longer judged only against its own history, but against sister operations in other countries. In 2005, ThyssenKrupp sold its metal cutting group to MaxCore and Silver Point Finance. The package included Cross-Hüller, Hüller-Hille, Hessop, Witzig & Frank, Giddings & Nuys, and Fadal, and was folded into MAG Industrial Automation Systems alongside Cincinnati Lamb. Once again, Fadal changed owners not because of a stand-alone decision about Fadal itself, but because it was one line in a larger transaction. The contrast with 1969 is hard to miss. When the old Bridgeport changed tools too slowly, the people who saw the problem, designed the answer, paid for it, and lived with the results all worked in the same shop. By the mid-2000s, decisions about Fadal had to compete for resources against machine tool businesses spread across multiple countries. That distance does not automatically create bad decisions, but it does remove the direct feedback loop that had shaped the company from the beginning. While Fadal was passing through corporate hands, Haas Automation followed a remarkably similar product path. Fadal is often compared with Haas because both were born in Southern California, both began by solving a shop floor problem, both moved from accessories into complete machines, and both built reasonably priced VMCs with in-house controls for the same kind of job shop buyer. Both also challenged the assumption that American machine builders could not compete with imports. The timeline matters, though. Fadal got there first. The VMC 45 was sold in 1980, and the VMC 40 appeared in 1983. Haas Automation was founded in 1983 to make rotary indexers and did not introduce the VF1 until 1988. Fadal was sold near its peak and then moved through multiple parent companies. Haas remained centered around its founder. That does not prove concentrated founder control is always superior. Gene Haas himself later created serious legal problems, a reminder that one individual can magnify mistakes as easily as strengths. But continuity does help explain why two companies with such similar origins entered the 21st century with very different levels of control over their own future. Even after all the ownership changes, Fadal retained one advantage no transaction could erase. Thousands of machines were still in service. Those machines created enduring demand for spare parts, technicians, and knowledge, regardless of who owned the logo on paper. That installed base kept the name alive. It did not guarantee that new machine production would continue forever. In 2008, the Chatsworth facility closed. That factory had once symbolized the years when Fadal's revenue rose from $5 million to well over $100 million, and when 11 scattered buildings had been consolidated into one 220,000 square foot plant where Fadal machines built parts for the next generation. Production there ended in 2008, though not as a clean overnight collapse. MAG continued promoting VMC products during the transition, and in 2009 announced product, location, and service network changes. Fadal had standardized enough components and sold enough machines that an aftermarket ecosystem survived. Thousands of machines running similar controls created a service market where technicians could specialize and where carrying the same common spares actually made economic sense. The repetition that had once accelerated the production line in the 1980s also, unexpectedly, helped keep the machines alive after the original factory was gone. Individual experiences varied, and no brand can be judged from a handful of surviving machines, but enough 1980s and 1990s era Fadals remained serviceable that they were bought, upgraded, and put back to work by shops that could not afford new equipment. Fadal did not disappear. Quietly, it restarted. In July 2014, Fadal Engineering and Merrill Technologies Group, a family-owned manufacturer in Michigan, announced a new CNC line to debut at IMTS in Chicago, 40 years after Dave's truck journey. The classic series included the VMC 2516, VMC 30016, VMC 4020, VMC 6030, and VMC 8003, intended to evoke the legacy boxway machines. Plans also included turning centers, with production in Michigan and California and global distribution. This was not a seamless continuation of the old factory. 6 years after Chatsworth shut down, the supply chain, workforce, control systems, and market had all changed. Haas had become a volume giant. Builders from Japan, Taiwan, and South Korea covered multiple price bands. A familiar name might make buyers stop at the booth, but it would not create orders by itself. The new Fadal had to retain enough of the old philosophy for longtime users to recognize it, while proving the product was more than nostalgia wrapped around outdated technology. One figure in that later story was Troy Alwyn, who had worked in CNC since 1990 and became the exclusive Fadal distributor for Illinois and Wisconsin when Merrill Technologies Group began building the new machines. From that, he founded Alwyn Machinery Sales. A distributor sits between the builder's promise and the customer's consequences. The distributor gets the call when a shipment is late, explains the control, and deals with the spindle that stops in the middle of a job. After 10 years of growing alongside the modern Fadal product line, Troy and Alwyn Machinery Sales acquired Fadal in 2024, returning the brand to a family-owned business with direct experience selling and supporting the machines. There is a certain symmetry in that. The de Caussin family gave up control in 1995, and nearly 30 years later another family took it back. But history does not simply repeat itself. Troy Alwyn is not Francis de Caussin, and the 2024 machine tool market is nothing like 1983. Legacy creates an opening, not a result. Fadal still has to answer the market all over again. If you go back to the garage in 1955, Francis and his sons were not trying to create a brand mythology. They were trying to make old machines run faster so the family could keep earning. They started with $2,500, an 800-square-foot shop, and the practical knowledge of people who had stood at the machine. They survived a $17,000 bad debt. They hauled a prototype across the desert. They sold a tool changer because they could not manufacture enough of them fast enough. They watched the VMC 45 lose its edge when Japanese prices collapsed. They shut down the old job shop and bet everything on the VMC 40. By 1995, Fadal had sold nearly 10,000 machining centers, generated $138 million in annual revenue, and produced about 54% of the VMCs manufactured in the United States before the family sold the company for $180 million. It was one of the great machine tool startup stories in modern American manufacturing. Nearly 70 years later, Fadal remains a test of what industrial legacy really means. When a machinist stands in front of a machine and a job is waiting, sentiment does not matter for long. What matters is whether the machine earns its place. Now that another family controls the name, the same question returns in a new era. Can Fadal become Fadal again? If you enjoyed this video, like, subscribe to the Gear Archive, and leave a comment with your thoughts. Thanks for watching, and I'll see you in the next one.